Hello, my name is Jordan Gibbs here at the Career and Technical Ed of Gold Lake High School, and I'm continuing on my path towards my Comptia Network Plus certification, in independent certification class offered at Gold Lake. So for starters, um, to show you all what I've been working on is I've been going through Unit 3 of Testout's Network Plus course. I haven't made as much progress as I wanted in reality, because this is a big unit, much bigger than Unit 2. There's what, 6 sections in this unit, and I've gotten halfway done. Um, and to be honest, I still need to study and refine more. But I think the best way to show off what I know, again, like last week, is going through a presentation. So, for starters, um, one of the first unit, I believe, it went through twisted pair cabling, um, and basically in this unit we learned how these wires are made up. Like you'll see this one, for example, it has insulation. It has insulation on the wires, and it has the sheath, and it has inside these insulators. It'll have some copper. These copper wires could be either fully copper, or they could be I forgot what the name is. Okay, so they could be either be solid or stranded wires, which stranded, they're basically more flexible, um, but they have a they're less like kinetic, or not kinetic, but or less conductive. So uh, stranded stranded means less conductive, and solid means more conductive, but they break more easily because they're less movable since they're solid. We learned about the crimper tool over here. I've used one of these before. Um, I haven't used one in a while though, but basically you'll use your RJ45 crimper here to um, make to attach like an Ethernet connector to this cable. And how you do that, you strip the wire for about 1 inch, and you'll untwist the cables or twisted pairs, and you'll try to untwist them as least as possible, and just put the wires in a certain order. But I'll teach you about that later. Basically, there's plenum cables, riser cables. Riser is used for like vertical extensions, so that like there's less fires that go to multiple floors. Plenum rated cables are more fire resistant, and they're in like air spaces that are more flammable. And they have like, and the material made out of plenum cables and riser cables, they're different. You can use plenum cables in place of riser cables. Um, Also, the the disadvantages of these cables are that they're susceptible to electromagnetic interference, and they're also susceptible to eavesdropping, where like people could pick up data from your cables. Um, the way to fix these is shielding, right? You'll have like some like aluminum, I believe. You'll put those around these cables, and they'll keep like the ends twisted, which basically there's some kinetic thing that makes it to where there's less electromagnetic interference. You'll find out that there's different kinds of connectors, like RJ11, which would be used for like Cat 6, or like basically phone cables. Like you'll have phone lines, stuff like that. And then you'll have RJ45, which are like these, used for like Ethernet ports, like computers, connecting computers, supporting networks. Um, you'll find others like RJ45C, which are kind of identical. And then you'll have like GG45, which is used for like Cat7. Um, and then you also have Terra. I gotta go see on my notes real quick. Yep, it's GG45 Terra for like Cat7. And then Cat8 is RJ45. I think that's enough talking about twisted pairs. Um, so now let's move on to coaxial cables. I got a little diagram here. You got the outside insulation, copper mesh, um, insulation, and the copper wire itself. You have two different types of connectors. You have a BNC connector and an F-type connector. You'll use the BNC coupler if you want to connect two different types of, or two types of coaxial cable, or two BNC types. You'll have different grades of cables like RJ58, which are used for older Ethernet networks. You'll have RJ59, RJ6. RJ59 though, it's mainly used for like television. RJ6 is like television and networking stuff. Sometimes you could use RJ6 in place of RJ59, and the RJ59 and RJ50 or RJ6, they use the F-type connector, and the BNC connector is for RJ58. Next, we have fiber optic cabling. You'll see you have a sheath, you'll have cladding, which cladding basically just bounces the light off from like the interior, from the plastic or glass core, so that it just stays inside the fiber optic cable, which is glass or plastic. You'll find that most of, if not all, of these connectors over here will have ceramic foil, I believe, or ferrule. It's hard to pronounce. It did get kind of confusing, this part, because I would search up images like what is this word, right? And what does it look like? And I guess it's just this metal thing. You'll have a metal part, which is like the base of it, and then um, you'll have like the plastic, or I don't think it's plastic. It's probably like metal. I could search that up real quick. So apparently, from what I found out, it's like a ceramic material called zirconia. Um, and in its description is its smooth polished surface provides a precise and consistent mating surface for the fiber. So I'm guessing this is basically like an interface for the wire, or this this core. Um, and there's these are the types that I learned about. Actually, no, I lied. There's LC, SC, ST, MR, MT, RJ connectors, and then FC connectors that I learned about. And you'll see that the LC, SC, they both have like clips on them. They kind of work the same way. Like they'll clip into uh, a fiber optic place or port. You see, ST is different. Like you'll plug that in and then you'll twist it. And then you'll see that like on each end you'll have maybe a different type of adapter. I'm guessing that's what this APC is, UPC. I haven't learned much about those yet, but I should probably go research that. Anyways, you'll have two types of fiber optic cables. One will be a singular mode, and another will be a multi-mode. Basically, the difference between these two is that in single mode, you'll have this core be a lot smaller. I believe it's 8 to 10.5 microns, which is basically just like a really small measurement, really small strand. And then you'll have multi-mode, which is a bit bigger, between 50 and 100 microns, I believe, something around that number. You'll find that you'll find that single mode is like less or a lower. It basically makes the light travel in a singular path, whereas like multi-mode you'll see it bounce off a lot more. You'll see that these two different modes, they transmit different wavelengths of light. You'll see multi-mode only transfer 850 to like 1300 uh, nanometers. Had to search that up real quick, and you'll see that singular mode transmits 1310 nanometers to 1550 nanometers, which those are basically just different wavelengths in light. Some of them, single mode produces more light, and multi-mode produces less. Some descriptions of these is that single mode will go farther. It's more reliable on 10 gig networks, and you'll find that it's more expensive. Now for multi-mode, it's more cheap, but it has to go a shorter distance, right? Like for a household, it'll be fine for it'll be fine for transmitting signals, or like a small office. You'll see it there. But for single mode, they could travel a long, long distance, like 2 kilometers, and it still have like a reliable data transmission. So yeah, those are some different characteristics of the fiber optic cabling. Next, I moved on to how twisted pair cabling was constructed. And this, I believe this is kind of like a jack or whatever, or a jack port, I believe it's called, or a key jack, something like that. This is called a push down tool. You'll use it on these to push them down and to cut them. You'll basically take the blade here, the blade on this end, and you'll push it down on the excess to push it down and cut the excess. And this is where you also learn about the different types of strands, right? You'll see that for 568B that and 568A, that the only difference is between like the orange and the green. They basically switched places. And to show you better, I decided to put an Ethernet port here, and which shows a 568A configuration of the wires for an Ethernet port. And this, I believe, I talked about this a bit in the first slide. So basically, how this will work, you'll cut it like an inch, right, from the wire, and you'll straighten the cables out like we have here, and you'll push them through until they get past these copper. I believe that's copper. I don't know the word for them, but basically you'll push them through, and then you'll use your crimper tool to snap that excess off. Now you'll see you have two different kinds, and if you want to use crossover cables, you'll use like 568B and 568A. If you want to use straight through cables, you'll use just the same type on both ends. Like if you want to use a straight through for this one, you'll have the one side of the Ethernet, which has 568A, and then on the other end you'll also have the same configuration, and it'd be the same if it was B. But yeah, I think there are some differences in crossover cabling and straight through cabling that I want to go through. So basically, straight through cable, you'll see that um, obviously I talked about they have the same thing. They'll have the same configuration on both ends, right? But they're used for like maybe connecting like two switches that have an uplink port to it. You wouldn't use it for like connecting, let's say, two computers together. For that, you'd use crossover cables. And yeah, if a switch doesn't have an uplink port, that's also when you'd use the crossover cable. And the difference between the two is basically the crossover connects the the receiver end and the sender end. I guess that's the basic understanding of it. Oh, and for straight through cables, I mentioned like switch. You use it to connect two switches. You could also use it to connect a router and switch, a router and a modem, um, but not two computers, because then it like have receiving issues. I guess. At least that's what I learned. Um, I'm sorry if I'm not explaining this like as well as I should be, but I still need to do a lot more studying on this topic because it is a bit overwhelming at times. Um, the last thing I learned about is wiring distribution. Um, so basically, your internet service provider, when you get your internet, they'll put in a line, which is your demarcation point. When you're the the outside and the inside, when the mark between that is your demarcation point. A main distribution frame, or MDF for short. This is like a closet, a networking closet, that you'll have on like you'll see the demarcation point in the basement, and you'll see the MDF near that, and the IDF you'll see it like maybe a floor above it, or you might see it across. You'll use a vertical cross connect for like going on different floors of your building, or you'd use a horizontal cross connect if you're just going across. Now, let's say you're only on like the third floor, and you only own the third floor. Well, then you get a demarcation extension in order to extend that demarcation point up to where you are. And another thing I learned was like, let's say you have like a workstation over here, right? And you wanted to get that connected to the internet. Well, you could use an IDF. You place another IDF over there, and instead of running like a bunch of different Ethernet ports or cables over there, what you do is you use a special type of UTP cable, um, which UTP means unshielded twisted pair cabling, and those will have like 25 or 100 pairs, I believe, somewhere along those lines. And it'll connect to every workstation that you own. Now, those are the basics of what I learned. The reason why this is like so much is because there's also some labs that I've done. You'll see you have this lab right here, two more labs, or one more lab here, and then you'll have two more labs at the end of section 3 of unit 3. So basically, what this lab did is it's in its name. I connected a certain type of twisted pair cable. I believe it was a Cat 6 cable to a modem, or it might have been a phone cable. I don't think that's true though. But I also connected fiber optic cables in a lab, and I connected patch panels to cables, which is basically I was connecting switches and patch panels together using Cat 6 cables, I believe, and in the fiber optics cable, I believe I was connecting the server using fiber optics to a computer, I believe. And then I had to go through and configure the network settings for one of these labs. But I also did the practice questions for each unit. I do get to go back and do the vocabulary quizzes, but I've those are not that many points, I'd say. I just did the practice questions, and I think I'm gonna start like studying those a lot. And then like anything I'm not like confident with, I'm just gonna go back to my notes and study, and then confidently say I can do it. But yeah, those are some of the things I've done. I'm also gonna show you my notes real quick. So here are my notes. I took notes. Well, I had my ChatGPT take notes on every single uh, thing that I've done. Like use punch down blocks, a bunch of these are a lot of notes. So I was just giving you like the basic summary of what I learned. I have this image in there too. Sometimes I'll take screenshots of what I have. I print out the practice questions and the lab reports, and I have images of each things. Fiber optics. This was like such a long unit to take notes on and read. Because I only do this about an hour a day. Um, I would say about an hour a day, and I was trying to get through like one unit each day, um, which is really hard for some maybe like me. But yeah, these are some of the notes I've been taking and what I've been doing. Thank you for listening. For me rambling on, and I hope you have a good day.